Lesson 3.9 is applying the Pythagorean theorem and its converse. The converse just means its opposite. It means that if you have a right triangle, then the Pythagorean theorem will work, and if the Pythagorean theorem works, then you have a right triangle. Okay, we have this television screen over here. It says television screens are described by the length of their diagonal. So if you have a 27-inch screen TV, for example, that means that's the length of the diagonal. The Pythagorean theorem can be used to find distances and lengths such as the diagonal length of an HD TV screen. Amy is making a brochure for this HD TV screen shown above. The screen is 48 inches wide and 20 inches high. And Amy wants to know what should she put for the diagonal length. Well, the diagonal actually cuts the screen into two right triangles. So we can go ahead and figure out, in this case, the hypotenuse. So remember, one leg squared plus the other leg squared equals the hypotenuse squared. So 20 squared is 400. 48 squared is 2,304. That equals c squared. We will add those up to get 2,704 and then take the square root. So the square root of 2,704 is 52. So this is a 52-inch diagonal screen, which of course I'm sure we would all love to have in our house. Next, the length of a rectangular swimming pool is 50 feet and the width of the pool is 20 feet. I'm a picture person, so I'm going to go ahead and draw that, maybe. There we go. I'm going to draw that out. So I've got the length of my pool is 50 feet, and the width of my pool is 20 feet, and we want to know what the length of the diagonal is. So my diagonal, there we go, make it look a little better, cuts this pool into two right triangles, and the diagonal happens to be the hypotenuse. So again, I'll take 20 squared plus 50 squared equals c squared. 20 squared is 400. 50 squared is 2,500 equals c squared. When I add this up, I get 2,900 equals c squared. Square root it, and it says to the nearest tenth, so the square root of 2,900 is 53.9 approximately. And this is in feet. So the length of that diagonal is 53 and 9/10 feet. Okay, the next type of problem, they're asking us to find the distance here. So they want us to find the distance between these 2 points that are on a coordinate grid. So what we can do is we can draw the distance right here and see what happens if I go from one point over to the other, underneath it, and then up. What have I made? A right triangle. So in this particular case, I know that this vertical distance is 2 and this horizontal distance is 1, 2, 3, 4, 5, 6, 7. And I'm looking for the hypotenuse. So I'll go 2 squared plus 7 squared equals c squared. 2 squared is 4. 7 squared is 49 equals c squared. When I add these, I get 53 equals c squared. Let's suppose that my directions say, let's go ahead and round this to the nearest tenth. So the square root of 53 is about 7 3/10. So about 7 3/10. Okay, that actually leads us into the distance formula. So let's look back here real quick. If I notice my distance here of 2, because I don't always want to have to draw pictures for this if they're asking me to find the distance between two coordinates. So my distance, my vertical distance, vertical is controlled by the y's. And notice my y is 6 and my y is 4. So if I take 6 and I subtract 4, I'm going to get a 2. And my horizontal is controlled by the x's. Well, 10 subtract 3 is 7. So that gives me these vertical and horizontal distances, which happen to be the lengths of the sides of the right triangle. So I can then square them, add them up, and square root. So here is the actual distance formula. So you need to pause it right here and write down this distance formula. It's a pretty basic formula. D equals, we've got this big old square root sign, and it's showing you subtracting the x's. When I subtract the x's, that's going to give me the horizontal leg. I subtract the y's, that's going to give me the vertical leg if I think about my triangle. Once I get those, I'll square them. It's like saying leg A, leg B, square, square, add them up, and then square root. So again, make sure that you write that formula down. So here, they don't want us to draw the picture. They want us to find the distance between these 2 points to the nearest tenth. Well, it might help us if we label them. This one is x1, y1. This one's x2, y2. Now I can just plug it into my formula. So it says take the x's and subtract them. So my x, I'm going to go 6 subtract 1, and I square it. And my y's, I'll go 3 subtract 9, and I'll square it. So now I just have to do the arithmetic. 6 subtract 1 is 5, so I have 5 squared. 3 subtract 9 is actually a negative 6 squared. The good thing though is, remember, when you square a negative, you automatically get a positive because a negative times a negative is a positive. So that's kind of nice because we know we can't take the square root of a negative. 5 squared is 25. Negative 6 squared is positive 36. We'll go ahead and add these up. 25 plus 36 is 61. And now I take the square root of it. And the square root of 61 is 7.8. So 7 8/10. Let's try another one. I will let this be x1, y1, x2, y2. It really doesn't matter which ones you let be the ones and the twos as long as you're consistent. So my distance, I'm going to set up my little template here. Now I can just plug in the values. y2 is negative 5. Oops. Well, it doesn't really matter, but we're going to do x2 first in the formula. So x2 is negative 3. x1 is negative 1. y2 is negative 5 minus y1 is negative 7. We have a whole lot of adding the opposite going on here. So add the opposite, add the opposite. So my distance equals the square root, negative 3 plus positive 1 is negative 2. Negative 5 plus positive 7 is positive 2. Now notice this doesn't become 0 because it's not negative 2 plus 2. It's negative 2 squared, which is a positive 4, and a positive 2 squared, which is also positive 4. So square root of 4 plus 4 is the square root of 8. And when I square root 8, I get 2.6 up, oh, I'm sorry, 2.8 approximately. So 2 8/10 if I round it to the nearest tenth. So there's your distance formula. Okay, remember I talked about the Pythagorean theorem, and the converse works. Basically, the converse says that if a squared plus b squared equals c squared, then it is a right triangle. So they're going to ask us to decide, is this a right triangle? Remember, this hypotenuse always has to be the longest side. So it doesn't matter if I make A7 or A24 as long as the hypotenuse is the C, the 25. So I'll go 7 squared plus 24 squared equals 25 squared. Now I just have to do the arithmetic. 7 squared is 49. 24 squared is 576. And I have to know, does that equal 25 squared, which is 625? So I'll add them. 49 and 576 does actually equal 625. I would take it down to this final step and I will say yes. Let's try this one over here. I have 10 and a half squared plus 36 squared. I need to know, does that equal 50 squared? 10 and a half squared is 110.25 plus 36 squared is 1,296. 50 squared is 2,500. So now I need to go ahead and add these together. 110.25 plus 1296 is 1,406 and 25 hundredths. That does not equal 2,500, so the answer is no. The answer is no. Ooh, all right. Katie, Ralph, and Juan are tossing a football. Katie is 22 and a half feet away from Ralph. Ralph is 58 and a half feet away from Juan, and Juan is 54 feet away from Katie. Do the distances form a right triangle? Well, I have to see if the Pythagorean theorem would work. And let's ask ourselves, which of these has to be the hypotenuse? I look at the three values, and it has to be the largest one. So I have to see, does 22 and a half squared plus 54 squared equal 58 and a half squared? So I'll figure it out. 28 and a half squared is 506 and 25 hundredths. 54 squared is 2,916, and 58 and a half squared is 3,422 and 25 hundredths. So now I'm going to add the first couple numbers. And lo and behold, I get 3,422 and a quarter equals the same on the other side. So yes, they do form a right triangle. All right, that is it as far as your notes are concerned. So this is lesson 3.9. Page 140 to 141. If you want to get started on this, it's going to be problems 9, 10 to 28 even, 29, 31 to 33, 37, and 38. If you want to get started, you're welcome to.